Hey folks, we're going to talk about Hess's Law and what that's all about. Uh, we are supposed to calculate the delta H for this reaction down here. So I look for carbon as a solid somewhere up here, and I notice it's up here. I notice it's on the left-hand side of the reaction, and I notice there's one of them, only one of them. So that reaction looks great as it is. So I look for oxygen, and when I find oxygen, I actually find it in two places up here, so I'm going to ignore it because it's hard to balance. So I'm going to look for CO2. And I notice that CO2 as a gas is only in one place. It's over here. It's on the right side of this arrow, so it's a product. It's a product over here, and there's only one of them on both sides, so that looks good. So I think if I combine these two equations, I get C plus half an O2 plus CO plus half an O2, and that gives me, on the right-hand side, CO plus CO2. All right, well, I notice I've got CO on both sides, so they cancel. And I notice I can combine these two, so I get C plus O2 gives me CO2. And that's exactly what I'm looking for here. And so if I take these two numbers that are over here on the left, the negative 110 and negative 283, and I add them together, I get negative 393.5 kilojoules, and that is my delta H for this reaction. All right, I am trying to find PCl3. Well, I notice that when I look for PCl3, PCl3 is only here. So it's on the wrong side of the equation. So I have to change that to a positive 640. All right, so I have to change the sign of this because I'm going to have to flip this equation around. The problem also is I have two of them and I only want one. So I'm going to have to take this and I have to divide it by 2. So that number is going to be a positive 320 when I'm all done there. Right. Now how about this one? Well, I look for chlorine. Chlorine again is in two places, just like oxygen was last time. So I'm going to leave it alone and ignore it and hope it balances. And I'm going to look for PCl5. Well, PCl5 is on the right-hand side, but I've got two of them and I only want one, so I have to divide this by 2, so I get negative 446. So I should be able to just add those two numbers up and get a negative 123 kilojoules. And that should be the answer to my problem. Let's verify that just to be sure. I'm going to flip this first statement around, and I'm going to divide it by 2, so it becomes PCl3 becomes P plus 3 halves Cl2. And I'm going to take the second one. The second one we said was fine, except it has to be divided by 2. So I'm getting P on the left plus 5 halves Cl2 gives me PCl5. All right, well, let's see. I've got P on the right-hand side here. I've got P on the left-hand side there. They're going to cancel. I've got 5 halves Cl2 on the left, and I've got 3 halves Cl2 on the right. So 3 halves go away, so I'm left with 1 Cl2. So I end up with PCl3 plus Cl2 gives me PCl5. And that's exactly what I was looking for here, so the negative 123 kilojoules is correct. All right, what am I looking for here? Well, I'm looking for a C2H5OH as a liquid, and that looks like it's right there. So it's on the proper side, and it's the proper number, so it's okay as it is. And I'm looking for CH3OCH3. That's right here. It's on the wrong side, so it has to go on the opposite side. So all I have to do is change that sign to be positive. So I add those two numbers together, and I get 93.6 kilojoules. So that should be my answer. So I can check it by taking the first equation, which I'm leaving as is. OH plus 3O2 gives me 2CO2 plus 3H2O. And I'm taking the other one and I'm reversing it, so I get 2CO2 plus 3H2O give me CH3OCH3 plus 3O2. Well, let's see, the 3O2's cancel. I notice that. And I notice the 2 CO2's cancel. And I notice I've got 3 waters that cancel. So I'm left with, I'm left with exactly this equation. And so the 93.6 kilojoules is correct. You're starting to see a pattern as I do this? All right, let's look for CuCl2. CuCl2 is here. The only place it is, it's on the wrong side. So I have to make this a positive 206. Okay, and The CUs are in multiple places, so I leave them alone. So I look for the CuCls, and the CuCls are here. They are simply on the wrong side. Well, where are they supposed to be? CuCl is supposed to be on the right, and there's supposed to be 2 of them, so that looks okay. So that's a negative 136. So if I take those and subtract them, I get 70 kilojoules. So 70 kilojoules looks like it should be the right answer. Let's see what happens. Let's take this first one and reverse it. So it's CuCl2 becomes Cu plus Cl2. And my second one we said was okay as is, so that's 2Cu plus Cl2 gives me 2CuCl. All right, well, let's see what happens. Well, I've got Cu on the right, and I've got 2 Cus on the left, so I'm going to end up with just 1 Cu on the left. And the Cl2s disappear because they're on both sides. So I've got CuCl2 plus Cu gives me 2 CuCl2. I'm sorry, 2 CuCls. And that looks right. So our answer of 70 kilojoules looks great. How about this one? I've got 2 F2s. I'm looking for F2s. F2s are only there. So it's on the proper side, but I need 2 of them. I've only got 1, so I have to take this number and multiply it by 2. So that's going to give me 2H2 plus 2F2, give me 4HF. And let's see, I look for water. And the only place I find water is right here, but it's on the wrong side of the equation. So I have to, but there are 2 of them. So this becomes positive 571.6. And this one I have to multiply by 2, so this becomes a negative 1084.4. And when I add those 2 numbers together, my delta H should be negative 512.8. Now let's see what happens. This is kilojoules, remember, sorry. So we said, let's see, we're switching this one, so this one has to turn around and go backwards. So it's going to be 2H2O gives me 2H2 plus O2. Let's see, the 2 H2s are on both sides, so they cancel. So I'm left with 2F2 plus 2 H2Os give me 4 HF plus O2. Looks good to me. That's the equation we wanted, so that delta H is good. Okay, let's go on to our next page. Let's see, I'm looking for XEF2. The only place it is right there, so it's on the wrong side, so I have to flip this to become positive 123. All right, so let's rewrite that. Let's flip it. So that's XEF2 becomes XE plus F2. And my other one, I'm looking for F2. That's in both places. I leave it alone. XEF4, that's correct as is, so I leave that as negative 262. So that's going to be XE plus 2F2 gives me XEF4. I've got an XE on the left and XE on the right. They cancel. I've got an F2 on the right and 2 F2s on the left, so that just becomes 1 F2. So that becomes XEF2 plus F2 becomes XEF4. And that looks like the right answer, so I have to take these 2 numbers, add them together, and I get a negative 139 kilojoules. So that's good. Number 7. I look for N2. The only place I find N2 is here, but I only want 1. I've got 2, so I have to take this and divide by 2, and I'm on the wrong side. So it becomes positive 1530, and I have to divide it by 2. So that becomes 765. And let's see, so let's rewrite that because it's backwards. So it's N2, I divided by 2, plus 3 waters, give me 2 NH3s, plus 3 halves, O2. Let's see, I'm looking for O2, but that's in 2 places, so I leave it alone. I'm looking for 2 NOs. 2 NOs are only in the top. Now they're on the proper side, but I have twice as many as I want, so I have to divide this also by 2, and that becomes negative 585. So let's see, I'm just dividing by 2, so that becomes 2 NH3 plus 5 halves O2 give me 2 NOs plus 3 H2Os. Okay, the 3 H2Os cancel. That's easy. Let's see. I've got 2 NH3s. They're gone. And I've got this 3 halves O2. I got 5 halves O2. So when I get rid of 3 halves out of 5 halves, that's just 1 O2 on the left. So I end up with N2 plus O2, giving me 2 NO. That's the correct equation. So I take the negative 585, and I add it to the 765, and I get 180 kilojoules. And that's my final answer. Okay, number 8. Number 8, I'm looking for aluminum. And aluminum I only see in one place, which is right there. And there are 2 of them, and there are 2 of them, so that number is perfect. I don't need to change that. And I'm looking for Fe2O3, and the only place I find that is here, so it's on the wrong side, so I have to put it over there. But there is one of them, so that simply becomes a positive 821, so I had to change that. So let's see, I have 2 ALs plus 3 halves O2 gives me Al2O3. And since I flip this around, I get Fe2O3 gives me 2 Fe's plus 3 halves O2. Well, the 3 halves O2 cancel, so they're gone. So I'm looking at 2 ALs plus Fe2O3 gives me, I got these 2 things down here, 2 Fe's plus Al2O3. Looks like that equation. So I take the negative 1601 and I add to it an 821, that's positive. Okay, so I get a negative 780 as my final answer. That is in kilojoules. All right, only a couple more. Let's see, I'm looking for waters. I'm specifically looking for 2 waters. I've got water over here, but I've only got one of them, so I have to multiply by 2, and I have to change the sign because it's on the wrong side. So that's going to become 2H2O becomes 2H2 plus O2. I multiply by 2, and so that number, then negative 286. I'm multiplying by 2, I'm reversing the sign. You know something? That's a problem. Notice H2O is here and notice H2O is there. I shouldn't be using H2O. I'm confusing myself, so I'm not going to use H2O. Let's try that again. Let's look for H2 because H2 is only in one place. H2 is here. It's just on the wrong side, so this becomes a positive 286. And H2O2 is only on one side. It's over here. Again, it is also on the wrong side, so it becomes a positive 94.6. Now, in both cases, I only have one of each one. Now, if I add those 2 numbers together, I get 380.6 kilojoules. Let's see if that works out. All I'm doing is reversing both equations. All right, so I get H2O plus 1 half O2 gives me H2O2. And I'm reversing the bottom one also, which is H2O, gives me H2 plus 1 half O2. Let's see, the 1 half O2 is on both sides, so they go away. The H2Os, I've got 2 H2Os over here. All right, so I have to put them together. So I get 2 H2Os, and that's all I have on the left-hand side of the arrows, become H2 plus H2O2. There we go, that looks good. That's our right equation, so that must be the right delta H. All right, this is the only one we have with 3, but the logic still remains the same. I look for C. The only place I find it is here. I notice that I have 2. I only have 1, so I have to take this number and multiply by 2. I want H2. I've got H2 over here as a reactant, so that's good. So this number is fine. I don't have to change that equation at all. Now this bottom one, I'm looking for C2H2. C2H2 is on the wrong side. I've got 2. I only want 1, so I have to divide by 2. And I have to flip the sign because I have to flip this equation. So let's go back and look at each of these things. I'm multiplying the first one by 2, so it's 2C plus 2O2 yields CO2. My second one is fine as is, so I'm not going to change it. H2 plus half an O2 gives me H2O. And my third one, I have to flip around, and I have to divide by 2. So I'm going to flip it around, so I'm going to start over here. So it's 2CO2 plus H2O give me C2H2 plus 5 halves O2. All right, now my equations, let's look at my numbers here. This one I had to multiply by 2, so that's going to become a negative 787. And this one is still a negative 285.8, 0.0. And this one I had to divide by 2 and change the sign, so it's positive now instead of negative, and it's 1299.4. All right, so let's go and see what happens when I add all these together. Let's see, I've got 2 C's over here. I don't have anything to knock it out. I've got an H2 on the left. I don't have anything to get rid of it. I've got 2 CO2s. Well, I do have something to help me out. All right, I made a mistake here. I multiplied by 2. I multiplied by 2. I had to multiply by 2. I did not multiply by 2. So I made a mistake. 2 CO2s, 2 CO2s cancel. All right. Now over here, I've got 2 O2s, and I've got half an O2. That's 2.5, or 5 halves O2. That's the same as this. So they cancel out. And I've got a water on the left and a water on the right. So I'm left with 2C plus H2 give me C2H2. So if I look at these numbers and I add them all up, I get 226.6, and that's positive, and that's kilojoules. And that is it for Hess's Law. Hope that helps you folks. If you have any questions, please see us in class. Have a great day. Take care. Bye-bye.